Second, got me screaming.
Which one?
Once, got so, tried it a second time, it's horrible.
Which one?
The assignment 11. I just don't understand it. I'm getting quotients, but not remainders. Just can't figure it out.
That's weird.
I don't know if I'm not doing the format right or something, but
I can take a look after class.
yeah.
I didn't really understand like when it asks to fill in the last portion of it, like it says to rewrite it in a different form. And it's like the form of like the remainder plus, or I'm sorry, the quotient plus the remainder. And like same thing, like I'm able to find quotient, but I can't, life is.
If it's a plus remainder over the divisor.
Yeah, but one thing I'm wondering is sometimes they want remainder over divisor, sometimes they just want remainder. How do you know when to do
I'll have to
which?
take a look.
Yeah, I don't know.
There's like an example where it says the divisor times the quotient plus the remainder is like the format.
Right, they may want that as well.
Instead of like how you said it, where it was the quotient.
Well, because that's the original, so that the divisor times quotient plus remainder is the actual form of the division algorithm.
And I even tried to check my answers by multiplying my quotient times the divisor to get the dividend plus the remainder. And it worked,
Yes, which was as it should, right?
but it's still marking my remainders
I'll
wrong.
take a look.
I had a question on the board too. It was like last problem of one of them, and it was asking for,
Well, your last problem is going to be different from someone else's.
like, it was asking for the final result of the polynomial, like not the remainder, but like whatever.
But we'll take a look after class. That's fine. Happy first day of March. February is now over. That's exciting. We looked at dividing polynomials last time. What we're going to look at today is finding the roots of a polynomial, right? So roots of a polynomial are just the points where it's equal to 0. And that's true of any function. If I say roots of a function, it's just where does the function equal 0? Where is it across the x-axis? You're familiar with doing this for basic quadratics and really easy to factor polynomials from algebra. Right, but what we're going to introduce today will always work, regardless of the polynomial.
Sure.
And so there's several things that we want to look at. First thing we want to do is list out all of the possible rational zeros. And that's simple to do.
Oops, here.
So we're given a polynomial function f of x. P is a factor of the constant term. Q is a factor of the leading coefficient. then any rational zeros of f would be of the form p over q. And so rational zeros of a polynomial will be a factor of the constant divided by factor of the leading coefficients. Right, so look at our polynomial function. What is the constant term? Right, we'll just look at positive 24. And the leading coefficient is 1. Factors of 1, well, that's simple. Just 1. That's nice. Factors of 24.
Two, 3, 4, 6, 12. Oh, 3 and 8. You ever played that
Right.
card game 24? You ever heard of it? Get it, how, you get it for your kids. It's called 24. Take a look at it. Trust me. It's great for math teaching.
I prefer the old-fashioned method. Just browbeat it into them until they understand it.
24. Best math teaching game I've ever seen.
And so we said what it was 1, 2, 3, 4, 6, 8, 12, and 24, right? Divide each of those by 1, so they just stay the same. That's actually only half the list.
Oh, you're negative.
You can also have say negative 1 times negative 24 is also 24. Right. Since technically it is minus 24, right? You have positive 1 times negative 24. There's a list of all the possible rational zeros. Right? Just because it's in this list doesn't mean it is a zero. It's just if we're going to have any rational zeros, it's going to be one of those up there. Right. Next, let's try and determine number of positive real zeros we can have and the number of negative real zeros we can have. This is done using what's known as Descartes' rule of signs. I think it's that.
I think there's an S on the end.
Probably Descartes. And so there's 2 parts to it. One part gives us the number of positive real zeros we can have. Second part gives us the number of negative real zeros. So the number f of x, the number of sign changes in f of x, less an even number. And so positive real zeros, number of sign changes that occur in f of x, less a real number. Or less an even number, sorry, not real. So positive, that's not a sign change. To negative, there's a sign change. Negative is not a sign change. So there's one sign change within f of x. So it'd be one positive real, less an even number. Well, 1 minus 2 is negative, and you can't have a negative number of zeros. So we're going to have one positive real zero, which is helpful. That is Descartes' rule of signs. So it says the number of positive real zeros you can have in a polynomial, number of sign changes that occur in f of x, less an even number. So just start from left to right. Positive, positive, that's not a sign change, right? Now it's minus, that's a sign change. So there's one. That's minus again, which isn't a sign change. So you have one sign change. So there's one positive real zero.
And plus 24, that would have been the second sign change.
Right, that would have been a second sign change. Second part of Descartes' rule of signs. Number of negative real zeros is the number of sign changes that occur in f of negative x, less an even number.
Oh, wait a second. What happened to the whole less and even number from part one?
1 minus 2 is negative 1, right?
Right,
You can't have a negative number of zeros.
right.
So there is no less than even number. You're guaranteed one positive real zero. Right, so if there would have been 3 sign changes, you could have 3 or 1 real zero. And I think we actually encounter something like that with the negatives. So you see what less than even number means. Write out f of negative x. Just replace x with negative x. Obviously, all the odd powers of x are going to change sign. Even powers of x stay the same. What's negative x cubed? Negative x cubed, right? What's negative x squared? Positive x squared, right? A negative number raised to an even power is always positive. Right? Count the sign changes. Negative to positive to negative. 2 sign changes. There's 2 sign changes. So you could have 2 negative zeros or no negative zeros. Negative. Right, so that's what less than even means. It would be 4 or 2 or 0. If we're dealing with the complex numbers, which we will be for these, then a polynomial of degree n will have exactly n zeros if you count multiplicities. Right, so multiplicity is something like if you have x minus 3 squared, 3 is a 0 of multiplicity 2. It occurs twice. So this is degree 3, meaning we're going to have 3 zeros. Sharp.
Degree 3 means 3 zeros.
Yes.
So
You're gonna have-
degree 4 would
You're
be,
going to have exactly 3 zeros.
so degree 4 would be
4 zeros. Again, if you're in the complex plane.
Because some of them could be imaginary.
So what we're going to do is just list out the combinations. We have to have one positive. Right? For the negatives, you could have 2 or 0. In this first scenario, 1 positive, 2 negatives gives us 3 zeros, right? So we're going to have no complex. In the second scenario, we have 1 positive and no reals. That means we're going to have 2 complex to have the 3 zeros. Now your number of complex zeros is always going to have to be even. Means z is a complex number. This here?
No, before that.
This is if.
If.
Right, so if you have a complex 0, so z is a complex number, it's a 0 of f of x, then its conjugate is also a 0. So complex zeros always occur in pairs. And we just check our combinations. Just make sure that they make sense. Right, each combination gives us 3 zeros. That's good. And the complex zeros are all even. So that's also good. Which means our result when we find the zeros has to match one of these. Now let's go and find them. So in order to be a factor of a polynomial, it would have a remainder of 0 when divided, right? Remainder theorem says if you take x minus a, right, f of a is the remainder when you divide f of x by x minus a. So if the remainder is 0, that would mean that f of a is 0, so a would be a 0. That's what we're going to do. We're going to test all these rationals.
Using the
Syn-
remainder theorem?
yeah, we'll use synthetic division. And if we get 0 as a remainder, we know it's a 0. This is where it can get tedious. We have to check until we get a 0. If you just choose randomly, you could be there for a while. I personally have a system. I always start with 1 because that's the easiest to work with. And then I work my way up from there. Coefficients of our polynomial, right? 1, 3, -10, -24. I'm going to write those out. And just so I don't have to write out the synthetic chart all the time, I'm just going to do it all in one chart. I'm just going to write 1 here to represent that I'm now checking x minus 1 as a factor. And then remember how synthetic works. The first drops down. 1 times 1 plus 3 times 1 minus 10 times 1 minus 24. It's not 0, so x minus 1 is not a factor. Right, that remainder has to be 0. Well, it's going to tell me if it's a rational 0 or not. Right, so what this is saying is f of 1 is -30. That's the remainder theorem. That's what the remainder theorem says. Yeah. So 1 is not a 0. Bummer.
Sorry, could you, all right, 1 into 1,
Right, so 1 times 1
yeah,
plus 3. Synthetic division. Remember that?
Yeah.
It's 4, right? Yeah, so I'm not doing it the way we did it yesterday because then I'd have to use up a lot of room.
Okay, all right.
So I want to try and do it all condensed together.
So then 4 -10 negatives. Okay. 6.
So you see what I'm doing now?
Oh.
1 times 2 plus 3 times 2 is 10, minus 10 is 0. I can stop because I know I'm not going to get a remainder of 0. In this case, the remainder is -24. Right, that means f of 2 is -24, so that's not a 0. So now check 3. 1 times 3 plus 3 times 3 minus 10 times 3 minus 24 is 0. 3 is a 0. So what I'm going to do is I'm going to box this. This means that right now we can factor f of x this way. X minus 3 is a factor. Times the quotient. Right, so this is where the division algorithm comes in. So we're writing f of x as a divisor times a quotient plus the remainder of 0. Right? Mm-hmm.
Hey, what?
What is x minus?
That's a factor, right? So remember, synthetic division is when you divide a polynomial by x minus a. 3 was a, right? So we're dividing our polynomial by x minus 3. So it's quotient, right? X squared plus 6x plus 8, and no remainder. So there's the divisor, times the quotient plus remainder of 0. Right, so 3, so because 3 is 0, that's why I'm using it. The idea is you want to keep doing this until you get a quadratic. Because quadratics are easy to solve. Right? You either factor it simply, or you use the quadratic formula. Can x squared plus 6x plus 8 be factored?
Yes.
What does it factor to?
X plus 2 times x plus 4.
Now we want that to equal 0.
So
And
you only have to, as soon as you found that 1, 0, you're done with the,
in this case, because it's a cubic, I keep going until we get down to a quadratic. Oh, don't worry, there's plenty. I don't remember if I have a 5th degree polynomial, but we've got plenty of them. Well, now the 0 property, right? X minus 3 is 0, or x plus 2 is 0, or x plus 4 is 0. So the zeros, -4, -2, and +3. Now you just check. Does it satisfy one of the combinations we already had listed? It does, right? 1 positive, 2 negative. Excellent. -4 and -2, were they in our list of rational zeros? They were. So we're good. That's what these are, yeah. Those are the possible rational zeros. Right, so any rational zero would have to be one of these. Based off of factors of the constant divided by factors of the leading coefficient. Leading coefficient was 1, so that's why we were just able to list those. There you go. That's the method. It's tedious, but not really difficult. The method itself isn't difficult to understand, right? Here we go, 4th degree. Again, let's start off by listing out the possible rational zeros. So factors of the constant. So what is our constant? So what are its factors? What was it? 1,
1, 2, 3, 6, 9, 18, and plus or minus whatever.
So again, this is how I started. Just list out all the factors of the constant. Now look at the leading coefficient. What's the leading coefficient? What are the factors of 3? This is now all the factors of the constant divided by 1. But we also have 3 as a factor of the leading. So divide each of these now by 3. Three divided by 3 is 1, which we already have listed, so no need to rewrite it. 6 over 3 is 2, 9 over 3 is 3, and 18 over 3 is 6. Those have already been listed, so there's no point in rewriting them. So this would be a list of the possible rational zeros. Because they're already up there, right? 3 over 3 plus minus 1. We already have it.
And those are called rational zeros?
Yes, those would be the possible
Possible.
rational zeros. Right. In other words, if f has a rational zero, it's going to be one of those. See how many positive real zeros we can have. Starts off plus to plus to plus to minus. There's a sign change to minus. One sign change. We're guaranteed a positive real zero. Negative reals. So we want f of negative x. Well, again, remember, even powers of x aren't going to change sign, right? Because -1 to an even power is +1. But the odd powers will change sign for f of negative x. So I'm just going to write 16x cubed switches to minus. 9x switches to plus. Everything else is going to be the same. Plus to minus is 1. The plus is a second. Plus to minus is a third. We have 3 sign changes. That means we have 3 or 1 negative real zero, right? 3 less than even. If we account for multiplicities, how many zeros are we going to have? If it occurs more than once. Right, so x minus 3 squared is a factor, then 3 would be a 0 of multiplicity 2. Right, because x minus 3 occurs twice in the factorization.
-3.
If x minus 3 squared,
I mean, the quantity squared.
yes, is a factor of your polynomial, then 3 is a 0 of multiplicity 2. Right, because it occurs twice in the factorization. Accounting for multiplicities, how many zeros do we have? What's the degree? So how many zeros do we have?
Oh.
4. We're gonna have 4 zeros. Let's list out the combinations. Could have 1 positive, 3 negatives. Then how many complex would we have?
0.
None, right? Because we already account for the 4, right? We're going to have 4 zeros. 1 positive, 1 negative means how many complex? There would be no other combination, right? Good. Complexes, number of complex zeros are even, as they should be, because they always occur in pairs. So we're going to result in one of these. We're either going to have 3 positives and 3 negatives, or 1 positive, 1 negative, and 2 complex. Set up the synthetic division. Coefficients 3, 16, 20, -9, -18. Now, in this case, we're guaranteed both a positive and a negative. So we're going to start off with 1. Test to see if 1 is a 0. 3 times 1 plus 16 times 1 plus 20 times 1 minus 9 times 1 minus 18. 1's not a 0. Now, since I know I'm going to be guaranteed a negative 0, I'm going to check -1. Right? In the previous problem, we weren't guaranteed a negative 0. That's why I didn't bother checking. Three times -1 plus 16 times -1 plus 20 times -1 minus 9 times -1 minus 18. -2. -1 is also not a 0. Let's check 2. 2 times 3 plus 16 times 2 plus 20 times 2 minus 9 times 2 is not going to be positive 18. So that's not going to be a 0. Let's check out -2. 3 times -2 plus 16 times -2 plus 20 times -2 minus 9 times -2 minus 18. -2 is a 0.
So that means factor x minus 2. X plus 2?
Yes, x minus -2. Remember, it's x minus a.
Oh. Yeah.
So x plus 2 factors out. Left with 3x cubed plus 10x squared minus 9. That's a cubic, which means we have to keep going. I'm going to check the rational zeros again. What are the possible rational zeros of 3x cubed plus 10x squared minus 9? Right, so we need factors of 9. Factors of 3 are 1 and 3, so divide each one by 3. Get plus minus 1, plus minus 3, plus minus 9, and then plus minus a third. Reference these with the original list. Are all of these in the original list? Yes, okay. We already checked plus minus 1, right? They're not possibilities. We already checked them. And if they weren't zeros before, they can't be zeros now. That leaves plus minus 3, plus minus 9, plus minus a third to check. Now, sadly, it was 1 or 3 negatives. So we still have to check the negatives. Yep, because we could still have 2 more negatives. If it was just 1 negative, we wouldn't have to check any of the negatives, right? Because we already had our 1, which would cut it in half. But sadly, we can't just do that. Right. Yep. You can keep going. But now look, if you kept going, you'd be checking ones that are pointless. Plus minus 2 cannot be a 0. Oh, I'm sorry. No. We just checked plus minus 2, right? Plus minus 6 can't be a 0. Plus minus 18 can't be a 0. Plus minus 2/3 can't be a 0 because they're not in this list. Right? So it's possible that you start to reduce your list, which is why I just stop after each 0. Coefficients are already given, right? 3, 10, 0, negative 9. Well, let's just start with 3 and see what that gets us. 3 times 3 plus 10 times 3 plus 0 times 3 is not going to be 9. Negative 3. 3 times negative 3 plus 10 times negative 3 plus 0 times negative 3. Oops. And then minus 9 is 0. Negative 3 is also a 0. That means we have 3 negative zeros. Because we just found 2.
You will have 3?
Yep. Right, because what were the possibilities? 1 or 3, right? If we have 2, then we're going to have 3. X plus 2, x plus 3 are now factors. We're left with what? 3x squared plus x minus 3. We've reached a quadratic. Can that factor? No, it cannot. No, I mean, it does, but not with rationals. So we're going to have to use quadratic on that. So we already have negative 2 and negative 3 as zeros. I mean, you can, but they're not going to be zeros. If they were zeros, this would have been factorable. Who remembers the quadratic formula? What's B? We're gonna have
Linear.
-1
Yeah.
plus or minus the square root of 1 squared minus 4AC. What is A? What is C? So we have -4 times 3 times -3 is going to be positive. It's 4 times 9. And then all over 2A, which is 6.
Really skip the surface one. I just like explain this.
B squared is 1, and square 1 together is 1, and then 4 times A times C, you did it all together, and it was 36.
Right, because it'd be -4 times 3 times -3. You get -1 plus or minus root 37 all over 6. That gives us a positive and a negative real zero, which matches 1 positive, 3 negatives. So the solution set, all of the zeros, I write them in descending order. The -3, -2, -1 minus root 37 over 6, -1 plus root 37 over 6. And there's all the zeros.
The negative real numbers, you got 3 or 1.
So, oh, I'm sorry.
How is it 3 or 1?
Number sign changes. So you know that's how we got the 3, right? Less an even number. So 3 minus 2. That's why it's 3 or 1.
So if you wanted to express those as factors, it'd be like quantity x plus 3 times quantity x plus 2 times quantity x plus quantity 1 minus.
If you're going to do plus, that means you're factoring out negative. It'd be 1 plus root 37.
And the other one would be x
Minus -1 plus root 37. Right, because it's x minus each of these.
Yeah.
So it'd be x minus -3,
All right, you gotta just.
x minus -2,
Negatives.
x minus this, and then x minus that. This one. This one right here is the bane of my existence. Again, start by listing out the possible rationals. Factors of 18. Leading coefficient is 4, right? Factors of 4. So now take each of the factors we just listed, divide them by 2. Plus minus a half. Plus minus 3 halves. Plus minus 9 halves. Those are the new ones. Right? 2 is a factor of the leading coefficient. So you have to divide each of these factors by 2. Right, remember? The rational 0 if it's a factor of the constant over the factor of the leading coefficient. P over Q. Four is also a factor. So go back to the first row and divide each of those now by 4. Two over 4 is a half. That's already listed. 6 over 4 is 3 halves. That's already listed. 18 over 4 is 9 halves. That's already listed. So we get a quarter, 3/4, 9/4 as our new ones. There is a list of all the possible rational zeros. Divide everything by divide everything in the first row by 4. And I'm not listing out repeats.
We decide to divide everything by 2 again.
Isn't 2 a factor of the leading coefficient? So you have to divide all the factors of your constant by 2. Because 4 is also a factor of the leading coefficient, right?
Because you could factor out the 4 to 2. Yeah, we did the 2, and then obviously with 4 because.
All right, factors of 4, 1, 2, and 4. Sign changes. Plus to minus is 1. To minus to plus is 2. You have 2 sign changes in f of x. That means we have 2 or no positive real zeros. You count the number of sign changes in f of x. Right? Positive, minus, that's a sign change. Minus isn't, right? Minus isn't. Plus is. That's 2 sign changes.
How would it be 2 or 0?
2 less than even. So 2 minus 2. F of negative x. Again, I'm just writing the signs that we're going to have above it. All of the odd powers are going to switch signs. The even powers stay the same. Right, so if you look at f of negative x, it's going to be plus, plus, minus, plus, plus. How many sign changes do we have? 2. Plus to minus to plus. Right in here. So we have 2 or no negative zeros. Oh boy. How many zeros are we going to need? In other words, how many zeros do we have?
No, there's fourth degree.
So how many zeros? Yep. We could have 2 positive, 2 negative, and how many complex would we then have?
0.
We could have 2 positive, no negatives, and how many complex would we have? We could have no positive, 2 negative, and how many complex? We could have no positive, no negative, and then how many complex? Good. All of the number of complex zeros are even, which they have to be. That checks out. We are going to be in trouble if it's that last one.
But we already were in trouble.
Oh, we are. But we're going to be in real trouble if we don't have any real zeros. Good news is for this course, you're always guaranteed to have at least one rational zero. Unless it's something that's easily factorable. Let's check the rationals.
Bigger sheets of paper.
You have no idea. So what I'm going to do for this one is I'm not going to go through all that I checked in my notes because we're going to be here for a while. 1 is not a 0. -1 is not a 0. 2 is not a 0. -2 is not a 0. 3 is not a 0. -3 is not a 0. 1/2 is not a 0. -1/2 is not a 0. Finally checked 3/2 and I got a 0. So for the sake of time, I'm going to skip right to 3/2. And I'm just going to say, I had a lucky first guess. You don't show your work to anyone. You go, it was obvious 3/2 was a 0. And that's what I mean by, depending on how you pick them, you could be there a while checking for the zeros. 4 times 3/2. -4 times 3/2. -7 times 3/2. -6 times 3/2. Plus 18 is 0. So x minus 3/2 is going to be a factor. We're going to be left with 4x cubed plus 2x squared minus 4x minus 12. Factors of 12. Factors of 4, 1, 2, and 4, right? So plus minus 1/2, plus minus 3/2, and plus minus 6. Right, 12 over 2, 6. That's something we don't have yet. Now divide by 4, plus minus 1/4, plus minus 3/4, and plus minus 12 over 4 is 3, which we have.
6 factor list at the top between.
Oh, I did, didn't I? Oh, whatever. It's now listed, so I'm not going to worry about it. And then 6/2 is 3, which is listed, and 6/4 is 3/2, which is listed. Right, so actually what I could do is, since I have technology, and then just go, what are you talking about? It's there. I didn't miss it. And I'll go ahead and I'll erase the this part of the recording so that there's no video evidence of it either. Oh, wait a minute though. 12 was not in our original list. Means immediately 12 is out. Everything else is in the original list, right? No, 4 isn't either. So 4 is out. We already checked ±1. We already checked ±2. Already checked ±3. And already checked ±1/2, and they weren't 0, so they can't be zeros again. Or they can't be zeros now. However, we did check positive 3/2 and it was a 0. It could be a 0 again, so you have to leave it in the list. By the way, we have one positive 0, which means we have to have 2. So we're guaranteed another positive real 0. Just hope it's rational. Well, I don't really feel like doing 6, so let's start with 3/2. Let's see if it's a 0 again. Good.
Wait, when you eliminated 4 and 12 from the factors of the constant,
Mm-hmm.
because they weren't in the original
Right.
list.
Which means, again, if it wasn't a 0 before, it cannot be a 0 now.
Now, the leading coefficient is now 4.
Still 4, yes. Leading coefficient won't change.
So 1, 2, and 4 are the factors of that, but
Right.
we have to cross off 4 again, because
Well, remember what we're doing is we're doing P over Q. Factors of the constant, which are 1, 2, 3, 4, 6, and 12,
right,
over factors of the leading, which are 1, 2, and 4. This first row are the factors of the constant divided by 1. Second row would be factors of the constant divided by 2, without writing repeats,
and it's divided by 2.
because that's a factor of the leading coefficient.
Okay, all right, so you cross off the 4 and the 12 from the first row, but you still,
Well, I did that afterwards. Right, I listed everything first, and then I cross-checked with the previous list. Right?
yeah, I'm just trying to understand why 4 didn't get crossed off the list of factors for the leading coefficient.
Because that doesn't matter. Because you're doing P over Q. Right, so first just list them all out. Then go and cross off.
To find out all these numbers that are plus or minus, we have to find the factor of the constant.
Mhm.
And then we have to find the factors for the leading term.
Yep, and then you divide each constant by each factor of the leading coefficient.
So that's why we did with 4.
Yep. So again, this is the method that I do, just to try and keep everything straight, is I just list out all the factors of the constant first. That's my first line. Then I look at the factors of the leading coefficient. In this case, we had 2 and we had 4, right? 1, you don't have to worry about. That's the first line. Divided by 1, you get the same thing. So now in the second line, I take each of those factors that I listed divided by 2. and I do not write repeats. Right, so 2 over 2 is 1. I do not write it because I already have it listed. Then I go back to those that I listed first, the first line, divide each of those by 4 without listing repeats. That gives me the third line. I just keep doing that until I've exhausted all of the factors of the leading coefficient.
9. Like,
Right, I divide each by 3 and then each by 9. And that's just so that I make sure that I list every single one without missing. Right, now, since this is the second step, we can cross some things out, right? We know that plus minus 4, plus minus 12 is not in the original list, so they can't be in this list, so just get rid of them. They're gone. Then you cross off all the ones that you already checked that weren't zeros, right? I mentioned I checked plus minus 1, plus minus 2, plus minus 3, and plus minus a half, and none of them were zeros in the first step. So they can't be zeros now, so they can be crossed off the list. So here's what we're left with the possibilities: plus minus 6, plus minus 3 halves, plus minus a quarter, and plus minus 3 quarters. Right?
why are we doing 3 over 2 again? Should we be doing negative?
Because 3 halves was a 0 before, right?
Oh, okay.
Right. It doesn't. So just because it was 0 once doesn't mean you can't have it as a second 0. Right. That's what multiplicity means. I mean, it could turn out that 3 halves is all 4 zeros. No, it can't be, because you have to have 2 negative, right? So you could have 3 halves and negative 3 halves as your 4 zeros, each one with a multiplicity of 2. Four times 3 halves plus 2
Okay.
times 3 halves minus 4 times 3 halves minus 12. 3 halves is a 0 twice. That means x minus 3 halves squared is a factor. And what are we left with? For x squared plus 8x plus 8. Let's make life easy. Factor out 4. It's not going to change the zeros. Right? Just makes dealing with quadratic formula easier because that cannot be factored. Right, quadratic, negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 2 plus or minus the square root of negative 4 all over 2, which equals negative 1 plus or minus I. Here's the beautiful thing about math: it doesn't care if you say no. The answer is still yes. Right, what's that saying? Math doesn't care about your feelings. Math is true regardless. Then you study advanced math and you realize it's actually the language of the universe. There's our two complex zeros. Three halves, -1 minus I, -1 plus I. Now just check. Does this satisfy one of our combinations? Which one? Second one, two positives and two complex. Then just make sure, are your complex zeros conjugates? They are. So there are your zeros. Now, if I asked only for real zeros, you would only have three halves. Right, so what this means is if you're looking for x-intercepts, you only have one. It touches the x-axis at three halves, it doesn't cross it. If the multiplicity is even, it just touches the axis. If it's odd, it crosses it. The multiplicity was 2, so I know it touches it. You think that's crazy? What do you do if you don't have any rational zeros?
How did the saying go? Shit out of luck.
Yeah, basically, in this course, you would actually need complex analysis to be able to find the zeros at that point.
And that we haven't gotten.
That's a level 400 math course. That's a senior level math course. So that's not something you're going to actually take unless you're a math major. And it's one of the last courses you take as a math major.
You took all of them.
No. I tried to take every math course I could, though. I'm looking into programs. I haven't applied yet. I still have to decide if my specialization and what I want to do research in. It's going to be tough because I just want to teach. I don't want to do research. So my research will probably be some kind of educational application. Problem is, I find those researches boring, though. Maybe I'll do research in if I can use mathematics to determine how happy someone is.
All right.
That could be help.
But you know, you have a math equation. Everyone has an equation. If I can determine your equation, I can determine the exact time that you're going to die.
Determine someone's equation.
That's the tough part. But if you can figure it out, you will know exactly when that person's going to die, down to the nanosecond.
I guess by the things they do, and you
No. Well, I shouldn't say that, because if there's a freak accident, I'm not going to know. I'm not going to be able to tell that. But I'm assuming that there's no accidents. If you know the equation, you would be able to know when someone's going to die, just based on entropy. Your cells deteriorate at a certain rate.
Is that how people could tell when?
No, that's something different. So they study the cancer and they figure out an average lifespan of So if you have this specific cancer, they study that. How long does someone typically live with that type of cancer? And that's how they give you the approximated. So when they say you're going to die in 2 weeks, that's just the average. Like Stephen Hawking was supposed to die before the age of 30, but he beat the odds because Lou Gehrig's has a average mortality of 3 years. He was diagnosed at 21. He was supposed to be dead by 24. He didn't die till like 80. He beat the odds. He's like,
What is that reset link?
no, that's an outlier. They kind of just throw that out.
They call it his disease.
No, it's not his disease. It's called Lou Gehrig's, named after a baseball player who had it.
He's that outlier.
Right, he's an outlier. Lou Gehrig's, when you're diagnosed, to 3 years. He lived for like 70 years. No, because it already had a name. Already had Lou Gehrig's. They're not going to rename it. Hawking has enough named after him. He doesn't need any more. X to the fourth plus 2x squared plus 1. We're all clever. We recognize this is quadratic. This is quadratic form. That factor is x squared plus 1 squared. X squared plus 1 equals 0. So what is x? Just I?
Oh, what, plus minus I?
Plus or minus I? Guess what? You just found all the zeros. Each one happens to be multiplicity too. How'd that happen? How'd what happen? Well, I mean, that's math, so. Isn't this of the form a squared plus 2ab plus b squared? That's a plus b quantity squared. X squared plus 1 quantity squared. So that's how that factors. So x squared plus 1 squared equals 0 means x squared plus 1 equals 0. So what's x? X squared is -1. X is plus or minus root -1, right? Which is plus or minus I.
A squared plus 2a.
A squared plus 2ab plus b squared is a plus b quantity squared. Right, it's a perfect square trinomial. It's one of the formulas you learned in algebra. I rephrase that. Should have learned in algebra. Algebra comes before geometry.
Yeah, no, we did that.
Algebra 1 comes before geometry. Yeah. Algebra 1's a prereq for geometry, actually.
And
You don't need geometry for algebra 2.
my high school had it set up.
I wasn't in high school anymore. So.
Took geometry and algebra 2 concurrently. You don't, the prereq for algebra 2, which is called intermediate algebra, is algebra 1 elementary algebra. You don't need geometry for algebra 2. Because a lot of students don't do 2 math courses in 1 year. That's why you typically do algebra 1, geometry, and then algebra 2. But you could actually do algebra 1, algebra 2, and then geometry. Or algebra 1 and then geometry and algebra 2 in the same year. Which is what I did. And then took the last quarter of the year off of algebra 2 because I was already guaranteed a 100. Went into that last quarter with like an average of a 200. So she put me aside. She said, "You don't have to do anything else the rest of the year and you're still going to get an A." Done. So I just slept. It was just awesome. Geometry, though. Only one of 2 math courses I actually ever tried and then got a C. Yep. Hated geometry. Loved the teacher, hated the course. Calc 3 is the other one. Oh, yes, this one. Okay. Another bane of my existence. Only good news is the leading coefficient. Factors of the constant. You socially counted just like my son. Except he only goes up to 10. Doesn't go up to. Oh no, actually, no, he did actually do the teens up to 20 with me. By the time he's 2 years now. By the time he hits kindergarten, he's going to be doing calculus. He'll have a PhD in physics by age 12. Unless he wants to get kicked out of the house. I'd be playing for the Phillies by 18. And then I'm retiring. Don't live off him. I disown him.
He's trying to take care of you.
I'd disown him. Mets, Yankees, nope. He'd be disowned in a heartbeat. Disown him. He's going to do something in the STEM field or high-paying sports. It's already decided for him. I'm going to make him think it's his decision, but it's not. Hmm? He doesn't need a gym. Everything he does at home. Oh my God. So this is again one where for the sake of time, I'm just gonna make a really lucky guess. Oh, I didn't do the positive or negatives. Whatever. It's a cubic. So it's not really going to be helpful. I'm going to start with -5. I'm going to check -5. 1 times -5 minus 2 times -5 minus 31 times -5 plus 20. It was so obvious -5 was a 0. Down to a quadratic. Can that be factored? I have a yes and I have a no. Who said yes? Who said no? Okay, so we're voting on teams. The team that is wrong gets executed. So vote carefully. Who's joining team? Yes, it can be factored. Oh, and by the way, if you don't choose, you're going to be executed on the spot. So you have to choose one team. It's the prison problem, basically. Uh-oh. Oh, dude. You're standing alone. Who's going on team no? Oh, dude, you're on your own. You're either going to be the luckiest man alive or you're going to be thrown in the pit alone. Sorry, dude. It's one less test I have to grade, though. This cannot be factored, which means we have to use quadratic. Should have brought my book with me. I'd throw it at him. Who said math isn't dangerous? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, wait. Why was I thinking that was 3? It's 4, so it should be minus 16. So 49 minus 16, 33, right? And then there are your zeros. One negative and two positive. Which if we would have done the chart, that would have been one of the combinations.
Let's say we didn't have your lucky guess. You have to do every single one.
Yeah, just check until you don't have to do every single one. You just check ones until you get a 0. Again, there's no one defined way to choose what you're going to test. You can just pick them at random if you want. Problem with that is, yeah, right. And if you do it that way and you don't write it out nicely, you may miss one. Right. So I like to keep everything like systematic. So I have a systematic way in how I choose on which ones to check. Could, or you could just pick lucky right off the bat. All right. So like I said, the method itself isn't difficult. It's just tedious. Right. So you're not going to have necessarily a hard time. It's just going to be tedious. Are there any questions on finding the zeros?
On the last one, we didn't even like try to find the positive.
Yeah, because I forgot. But I knew I was going to have at least one real zero, right? Because complex has to occur in pairs. So that means at most you can have 2 complex zeros. So you're going to have 1 real zero. Any questions?
If it can't be factored, it's automatically put in the quadratic formula.
If you can't factor the quadratic, it's going to be in the quadratic formula, yes. Even if it can be factored, you can just throw it into the quadratic formula. Right? Quadratic formula always works. You have to be careful. Read the instructions. Read what it's asking for. It may ask just for the real zeros, in which case you ignore the complex. These instructions said, find all the zeros, which means I am looking for complex. And then you move on to calculus and don't ever worry about that again. In my honest opinion, this is the toughest thing we do all semester. Not necessarily, again, because it's hard, but just because of how long it is. More chances for mistakes. I can tell you right now, the next unit is the easiest unit. I mean, it is stupid simple. So what do we have left? We have rational functions and then variation, and then we're done with unit 2. So unit 2 will probably conclude next week. So the unit 2 tests will be made available next week.
During the spring break,
No, Murphy.
oh,
It won't be due during spring break, if that's any consolation.
it'll be due on Monday before class.
No, probably not till Wednesday. Tuesday before class. We don't meet Tuesdays. No,
That's usually when.
they'll probably make it due. That's because it's the end of the day. I give you 1 full week. What are you talking about? If I make the test. Oh, wait. No, this is the 3rd. Oops. Okay. Yeah. Yeah. So it'd be over spring break, but it won't be due until the following week. So you don't actually have to work on it over spring break. Unlike my online classes, who didn't get a spring break. Huh? 2 weeks. Starts on the 13th. That entire week. We're getting there. We're at like halfway point of the semester. Brings us that much closer to my favorite topic. Trig.
We will be doing, you know.
Oh, we'll be doing trig, yes. Absolutely, we will be.
Like to teach it as well.
Yes. I love trig. Just everything about trig.
Go down a little bit. Oh, Jesus.
Oh, wait, you're executed. You don't get a quiz.
No take backs.
Okay, the same.
Just snap them.
That's what.